So next topic is to understand that sometimes the relationships are not linear. So we have already discussed the codes in R, how to check if the independent variable has a non-linear relationship. So the relationship between the independent and dependent variable may not be linear. Linear means that it is proportional at all times, but sometimes it is not true. So it is useful. The method that can be used to check if it is linear, not linear, is the quadratic or this quadratic graphs or scatter plots. So if the regression is non-linear, what will happen? The regression will become y is equal to b0 plus bi means that particular variable and its square form. The second independent variable is a square of a first variable. Okay, uh, this means that when you add a square of a particular variable, you are saying that that variable is xj is not linear in terms of variable variable. It's not linear. So it should. So we are testing for its non-linear effects. Uh, it can be polynomial. If it is more than 2, it could go to p. So if it is maximum power is 2, we can call it quadratic. Quadratic. 3 is cubic, and then if 4, it is polynomial of power 4, and 5 is a polynomial of power 5. So you have so it's p0 is a quadratic model with it's a polynomial of power 2 or order of power 2. So in real life, the more the bigger power, the more complicated the model is. So we as an analyst, we try to make sure that the lowest possible power is there to explain the model. We could add infinite powers, but what will happen is that it will make it extremely difficult to interpret in real life. That is why we simplify it. So if the model is complicated, first of all, we need to understand how to find if it is a complicated model. So this session is talking about this activity. So suppose we have a data set and the dots are following a bend, but you start with a straight line. What will happen? The straight line will pick the linear portion and the bended portion will go into residuals. And since the residuals and the independent variable are not straight, it will give us a problem. And what it is showing us, we are already discussed that if the residual are not straight line, it means it is heteroelasticity. So these residuals have heteroelasticity in them. So but if the dots are bending and you start with the bended line, what will happen? It will pick the bended portion and the remaining straight portion will go into residuals. So there is no residuals. So hetero comes when the residuals are expanding or when the residuals are shrinking. But if the residuals are actually bending, it is a type of hetero, but we call it non-linear residuals. Or in other words, the word that is used in books is misspecification. Misspecification. It is used in explaining the bended residuals. So if you do not use the actual model, what will happen in real life? Your model will not pick the specification and it will called as misspecified as like it's shown here. Okay, so let's move forward. So there could be 4 types, and it is given as an example. If B1 is negative and B2 is positive, it will look like this, and the complete picture will be U shape. Means B1 is telling us that it will decrease, and square is telling us it will increase. So it means it will decrease first and then increase later on. If both are positive, so it is U shape. Let's write it here, U shape. Let me clean it up. U shape, and this, and then if it both are positive, you can call it exponential positive, and if it both are negative, we can call it exponential negative. And if first is positive, second is negative, this shape is called inverted INV shape. So it means you can, in literature, we could find four types of nonlinear relationships. So we have to look at the values of B1 and B2 so that we can identify if it is a linear or not. And there are, since there are four types, so I've given the names. Next, we talk about the F test. So how to check if it's a non-linear model? So what will happen is, first of all, we'll estimate the quadratic model, and then we'll linear model. So we'll check it the t-test. First of all, we have to check if the overall model is fit. Mean if you add a square terms, the overall model should be significant, and then we'll go towards the t-test where we check if the x square variable is significant or not. If x2 is significant, b2 is significant, it means it is quadratic. If b2 is insignificant, if it is insignificant, then no need. So it's a linear model. So higher order could be like this. So it has two bends. It's a non-linear model. It's a cubic model. So how to know that it has a cubic? It is a cubic model. Since the data has three bends, so first bend, so data has changed its shape three times. First, it was positive, then it became negative, then positive. So it has changed its shape three times. Then it means the biggest power should be 3. So if it had another shape like this, I would have had beta 4x4. So this is the way we judge the models. So if it has two shapes, we will add x square, and 3, then 4 and 5. So in real life, you have to look the shape. Look at the shape of the line. If it is changing the angle three times, it should have 3 power. So it is talking about this thing. So this is a cubic line because it has changed. It has changed the slope by. It has changed the slope 3 times. Okay. Then it is talking about interaction of slopes. So have a look at here. So interaction between. So it is an interacting variable. So it is commonly known in literature as moderator. Okay, so you can see in regression there is a one y variable, an x square, then x3. So x1 as a square, then x1 multiplied by x2. So it means x1 is also multiplied with a new variable x2, and this is a moderator form. So cross product. So this is a cross product where x2 is moderator to x1. Similarly, here moderator is x2 and the moderated variable is x1 square. So we could use cross products. What is the purpose of them? Let's go and see what does it gives. Okay. So it has given us one example. It's a simple interaction. So x1 is a variable and it gives us effect of x1 on y. This is an x2 variable. It gives us effect of x2 on y. It gives us a joint increase of x1 and x2 on y. So this is the interaction variable. So let's see how it is giving us an example. So let's see, this is an example. Y is 1 as intercept plus 2x1 plus 3x2 plus 4x1 x2. So x2 is a dummy variable which is 0 or 1. So what we'll do is we'll put the 0 first, and we will have there will be no x2 variable, no x4. So what will happen? It will be a simple equation in a red line. So this is a simple regression line. And what is happening here? We put x2 here. So this becomes a constant. It is added in 1. So it becomes 4. And here this becomes 4x1. 4x1 has the same base as 2x1. This becomes 6x1. So 6 becomes a bigger slope. So in the previous model, the slope was 2. Now the slope is 6. That's why you notice that since the dummy variable is alone also and with the multiplication, so it has changed the intercept and also changed the slope. So we can call it it is known as interactive dummy. Interactive. So interactive dummy means that it is actually explaining how other variables are explaining. So when dummy is 1, it is changing the slope of other variables too. So the effect of slope is y. The effect slope on of x1 on y depends upon x2. So this is the definition of a moderator. How x2 explains the effect of x1 on y. So dummy variable could come like this. Either it could change intercept only, or it can also change the slope. So let's see what example it is providing us. So this is the data set where there is an observation number, data for y, data for x, data for the x2, and then data for x1 multiplied by x2. So here you notice that x2 is not a dummy variable anymore. It is a continuous variable, continuous variable. So this is a cross product of two dummy variables. So this is so it means for the case of cross products, you should know before when you are using it so that you can calculate them in your Excel file before going into regression analysis. Okay, so let's move to the last point. So here he has written the equation. So there will be a significant moderating effect if beta 3 is significant. The proportion that the proposition that there is a moderation in the model will be true if beta 3 is significant. So we are checking for the interaction effect by t-test. So this way we can check for the presence of the effect. Okay, so in the regression results you will have these values.